Hello and welcome to the Invent with Scratch screencast. I'm Al Swigert, and in this screencast we're going to make a small maze game. We can move this cat around using the arrow keys on our keyboard. You notice the cat can't go through the walls even if we try. And the objective of the game is to get to the very end of the maze. So let's go into how to create this program step by step. Go ahead and start up the Scratch editor by clicking on Create. And the first thing we'll do is we'll import our maze image. Now we could draw it ourselves by painting a new sprite, but instead I'm going to go to the inventwithscratch.com website and then click on the Downloads section and just grab this maze image by right-clicking on it and saving the image. And then back in the Scratch editor, I can upload this image from my computer to the Scratch editor by clicking on Upload Sprite from File. Perfect. And we'll just move the cat out of the way. Well, that cat is way too big for this maze. I'm going to have to grab the Shrink tool and then click several times on this cat to shrink it down. There we go. So we want our program to move the cat around whenever the player presses on the arrow keys on the keyboard. So in the Brown Events category, I'm going to grab this When Green Flag Clicked block. And then from the Orange Controls category, I'm going to grab the Forever block. And so this will run through the code that's in here forever. So we want it to check if a arrow key is being held down. So I'll grab the if block, and then from the light blue sensing category, I'll grab this key pressed block and fit it inside the condition socket for that if block. But I'm going to change this by clicking on the black triangle to left arrow. So this code will control moving the cat to the left. And to actually move the cat sprite, I'll go to the dark blue motion category and grab this change X by block. You want to be sure to grab the change X by and not the set X to block. And since we're changing the X coordinate to go left, we need to have this be a negative number. I'll say -4. Now we could go back and add all those other blocks for the other arrow directions, but I'm going to make a small shortcut. I'm going to right click on the if block and then select duplicate, and that'll give us a duplicate set of all the blocks already. And all I have to do now is just change this to right arrow, and since we're moving in the right direction, I want to change X by 4 instead of -4. Then I can duplicate this all over again by right-clicking on the top if block and selecting duplicate. And we'll have these if blocks control moving up and moving down. We don't want to change the X coordinate, we want to change the Y coordinate, so get rid of these blocks just by dragging them over the center area. And go back to the dark blue motion category and grab those change Y by blocks. And for the up arrow direction, we want to change this by 4, and for the down direction, we want to change it by -4. So let's click on the green flag and test this program out. That's pretty good. Well, the cat moves up, down, left, and right, but we don't want the cat to be able to move around the maze right through the walls like that. Also, the cat looks kind of spooky just gliding around, so we're going to add a walking animation too. So I'm going to click on the red stop button to stop the program. Let's also have the cat always start at the beginning of the maze when the program first starts up. So I'm going to grab this go to XY block and put it right at the start, right before the forever loop. So that means that no matter where the cat is, when we click the green flag, the cat will move back to the start of the maze. Now to animate this cat, the sprite comes with 2 different costumes, so you can click on the Costumes tab in the center to see them. And if we switch between the 2 costumes, we can get a sort of walking animation. And there are some programming blocks that let us switch the costumes. They'll be under the purple looks category. You can grab this next costume block and go ahead and put one next costume block inside each if block. Now when we click on the green flag, cat has a nice walking animation. Now we want to change the program so that the cat can't just go through the walls. And the way we'll do that is by checking if the cat is touching the black color of the walls. And if so, we'll cancel out whatever movement it just made. So inside this if left arrow block, we're going to add a new if block from the orange control section. And this will check if the cat sprite is touching the black maze wall. So in the light blue sensing category, grab this touching color block. We want it set so that if the cat is touching the black maze color wall. So we'll have to change this color by clicking on that color square and then clicking on the black of the maze walls. Now to undo the leftward motion that the cat just made because the user pressed the left arrow key, we're going to add a change x by block, except this block will change x by 4. So when the user presses the left arrow, the cat moves to the left, but if the cat ends up touching the black maze walls because of moving to the left, we'll have it counteract that by just moving back 4 pixels to the right. And we'll need this for each direction, because if you click on the green flag right now, you'll see the cat can't move through the walls to the left. Each time it's moving, it gets moved back by 4 pixels, back to its original position. But the cat can still move up and down and right through the walls. So I'll click on the red stop button to stop the program. I'll go ahead and right click on this if block to duplicate it for the other if blocks. So for the right arrow case, in this case to cancel out that movement, I'll need to change this to -4. And I'll duplicate that again for the up arrow if block. But we don't want to change X, we want to change Y for this block. So I'll get rid of that and grab this change Y by block. And since this is changing it by 4, to cancel that, we'll have to change it by -4. And then I can duplicate that one more time and have that change Y by 4. So let's test this program out. I'll click on the green flag, and we can't go up through the walls, or left through the walls, or down through the walls, or right through the walls. That's perfect. So I'm going to click on Paint a New Sprite to make a small red X that we can put at the very end of the sprite. So just something really simple, X. And I'll move that to the very end of the maze. Now let's add some code to the cat sprite so that it detects if it's touching the end goal sprite right here. Actually, let's change the name of this from something other than the generic sprite 2. Click on that info panel, change this to goal. So from the orange control category, I'll grab this if block. And then from the light blue sensing category, I'll grab this touching block. So if the cat sprite is touching the goal, then we'll just have the cat say I won. And we can do that in the purple looks category. We'll grab this say hello for 2 seconds. Except instead of hello, I'll click on that and change that to say I won. So let's test this program out. Yep, this way? Nope. Oh. Nope, another dead end. Oh, oh, hey, I won. Perfect. I'll click the red stop button to stop the program. You might want to add some more code that prevents the cat from just walking around the maze entirely and cheating. But I'll leave that up to you. Now if you want new mazes, you can either draw some yourself, or you can go online and go to Google and just search for maze generator online. And there are several websites that will just automatically generate mazes for you. I can click on this first link at mazegenerator.net, and you can see we can just keep generating as many different mazes as we want. So that's the entire program. In this screencast, we learned how to upload new sprites that we download off the internet. We also learned how to keep sprites from walking through other sprites by canceling out their motion after detecting if they're touching a certain color. So I hope you found this screencast helpful. I'm Al Swigert, and thanks for watching. Hello, and welcome to the Invent with Scratch screencast. I'm Al Swigert, and in this screencast we're going to make a small double jump demo. So in this program we can move the cat to the left and right using the left and right arrow keys, and we can press the spacebar to cause the cat to jump up. But not only that, we can also have the cat do double jumps. So I'm going to show you how this program is put together step by step. So let's start up the Scratch editor by clicking on Create. And since this is the first screencast, I'll go over some really basic Scratch things. So this area here on the left is the stage. We have all the sprites that appear in the program are on the stage, and we can also see all the sprites down here in the sprites area. We can pick up the sprite with the mouse and move it anywhere we want. This center area has all of the code blocks that we can add to our program. The code blocks will program the behavior of all the different sprites. And this area on the right is where we put the code blocks. So just to start off, I'm going to go to the Brown Events section and grab this When Green Flag Clicked block. And I'll increase the size of this to make it easier to see. So the program execution will start at this top block right here, and then continue down through any blocks below it. So the first thing I'm going to add is from the orange control section, and it'll be this forever block. The forever block will execute all of the code blocks in it in a loop forever, over and over and over again. So the first thing I'm going to have is, let's program this cat to move to the right whenever the right arrow key is pressed. So I'm going to add this if block from the orange control section, and then for the condition socket right here, I'm going to go to the light blue sensing category and grab this key space pressed. But I don't want the space key to be the key that's pressed. I want the right arrow key to be pressed. So click on the black triangle and select right arrow from the menu. So now, if the right arrow key is pressed, then the Scratch program will execute any code blocks inside this if block right here. So I'm going to go to motion, and the code that we want to execute will be this change x by 10. This will change the x coordinate position of the cat sprite by 10 pixels. So let's start this program out. I'll click on the green flag to start the program, and then press on the right arrow key. We can see the cat moves over to the right. Now the cat doesn't do anything when I press the left arrow key or any of the other keys because we haven't added that code yet, but I can pick up the cat with the mouse cursor and place him back over there. So I'll click on the red stop button to stop the program. Let's add some more code to this. Moving to the right is nice, but we should also be able to move to the left. So what we want to do is go to the orange control section and add another if block right here. But actually we can do a shortcut. If I right click on the if block and select duplicate, it'll duplicate all of the code blocks connected to it. Then I can just stick that inside the forever block underneath the first right. And then I just make some simple changes. Right here I'll change this to left arrow. And since I want the sprite to move to the left, I'll change this to -10. So now when I clicked on the green flag, I can move both to the left and to the right. But it's kind of weird that the cat just sort of moonwalks backwards whenever we move the cat to the left. Let's add some more code so that the cat is facing in the direction it walks. So back in the dark blue motion category, I'm going to grab this point and direction block. Just put that at the top right here. So 90 degrees is facing to the right, which is what we want when the right arrow key is pressed. When I grab another one of these point and direction blocks and put it in the left arrow if block, I want it to point to the left, which will be -90 degrees. So now whenever I click on the right or left arrow, it does two things. It points the sprite in a certain direction, and then it changes the X position. So I'll click on the green flag to test this program out, and going to the right, and going to the left, and that's kind of weird. Now instead of moonwalking, the cat's just sort of walking on its face. That's not healthy. Now the reason it's doing that is if we click on the info button here for this sprite, we can see that this short little blue line shows which direction the sprite is facing. So I'll click on the green flag. When I go right, you can see it's pointed to the right in the 90-degree section, and when I go left, it's pointed in the negative 90-degree section. And I can also just grab this blue stick with the mouse and rotate the sprite around. So you can see when it's facing the right, the cat is right side up, but as we rotate it over, you can see why it's upside down when it's facing to the left. So we can fix this by setting the rotation style to the left-right style by clicking on this blue button right here. And so now the cat will only be facing right side up to the left or right. I'll just use the arrow keys to move the cat around. That works pretty well. I'll click on this triangle to close the info panel. Next, we should move this cat down to the ground so the cat's not walking through midair. And we also want to have a walking animation. We don't want it to just look like the cat is gliding left and right. And you'll notice if you click on the costumes tab in the center right here, this sprite comes with two different costumes. Now costumes are different ways that a sprite can look. So these are the same sprite, but the sprite can change its appearance by activating a different costume. And you can see if we switch back and forth between these, we get a little walking animation. Now we can have our program change the costumes by adding some code blocks from the purple looks category. There's a code block right here that says next costume. So let's add that into this if block, and then add another next costume for the if block going to the left. Now when we click on the green flag and test this out, it actually looks like the cat's walking left and right. And I'll click on the red stop button to stop the program. So this is pretty good. But now we want it so that the cat can actually start moving up and down, and not just that, but also jump up and fall down in a realistic manner. So to do that, we're going to go to the orange control section, and I'll grab this if-else block and put it in underneath right here. So we want this code block to do two different things. One, if the cat is up in the air up here, we want the cat to start falling down to the ground. And if the cat is below the ground level, we want the cat just to be at the normal ground level. And we'll say that the normal ground level is right here at negative 130 for the Y position. Remember, the Y coordinates are the coordinates that go up and down. The X coordinates go left and right. So we need to add some code that says, if the Y position of this cat is ever less than negative 129 degrees, then we'll know that the cat is beneath the ground level, and so we'll want to move the cat directly to negative 130. So go to the green operators section and grab this less than sign. And then go to the blue motion category, and at the bottom you'll find this Y position bubble. Now the value in this Y position bubble will be whatever the Y value of the sprite is currently. And on the right side we can just type in negative 129. So in this case, we want the falling speed of the cat to be 0 and then just move the cat right to the ground level. So first we're going to create something called a variable, and that'll be done in the orange data section. Variables are blocks that can contain a number that we specify, and then we can use that number later in our programs. I'll show you what I mean. First we have to create the variable by clicking on the Make a Variable button, and we'll call this variable falling speed. I'll go into what for all sprites and for this sprite only mean in a future screencast, but for right now just have for all sprites selected and click OK. So now that we've created a variable, a whole bunch of new blocks open up to us. The first thing that we're going to want to do in our program is set this falling speed to be the number 0. So we can grab this set variable block and we'll put it at the very start of the program, right underneath when the green flag is clicked, but above the forever loop. That way, at the very beginning of our program, this variable will be set to the number 0. We also want the falling speed variable to be set to 0 whenever the cat is underneath the ground. I'll go into the reasons why later. But let's grab this set falling speed block and put that inside the if block. And then we also want to set the position to -130. So grab set y and change this number to -130. Now in the else block, this code will be executed if this condition right here is false. What that means for y position less than -129 is the code in the else part will be executed if the sprite is above the ground level, above -130. And what we want to do in that case is decrease the falling speed variable by 2, and then also change the y position of the cat by the number that's in falling speed. So first I'll go to the orange data section and grab this change block and set this to -2. So remember, the set falling speed variable will just set the variable directly to this value that's in the white box, whereas change falling speed will increase, or in this case, since we have a negative number, decrease the number that's in this falling speed variable. This is a lot like how change x will change the current x position by this number, whereas a set x or set y block will actually set it directly to this value. And next, from the dark blue motion category, grab a change y by block and put it inside the else block. We don't want to change it by this number 10, we actually want to change the y position by whatever the number is in falling speed. So go to the orange data section and grab this falling speed variable and replace the number 10 with it. Now if we click the green flag, we can see that the cat falls straight to the ground. Let's try that again. I'll just set the cat up here, have the cat fall straight to the ground. So what's happening here is that whenever the cat is above the -130 ground area, this condition is false. So falling speed will be changed by -2. Remember, at the start of the program, falling speed is set to 0. So when we change falling speed by -2, it gets set to -2, since 0 plus -2 is -2. And then we change y by whatever value is in falling speed, and since falling speed is a negative number, that means the cat moves downward. And then the next time this loop happens, this condition is still false, so we change falling speed by -2 again, and since falling speed was -2, it then becomes -4. And so we change y by -4, and that moves the cat faster than before. And then on the next time, falling speed changes to -6, and then on the next time it changes to -8, all until the cat is below the ground level, at which point its y position will be less than -129. At that point, we don't want the cat to be underground, we want the cat to be at the exact ground level of -130, so we set the y to -130, and to keep the cat from falling anymore, we set falling speed to 0. You can see the current value in falling speed. It goes by pretty fast right here, though. So you can see it started off at 0, and then you could tell that the number was becoming more and more negative until finally the cat sprite hit the bottom, at which point this code block sets it to 0. So I'm going to shrink this down by clicking on that arrow so that we have more space for the code. And let's add code that causes this cat to jump up. So I'm going to go to the brown events category and grab this when space key pressed block. Now the code that is underneath this block will execute whenever we press the space key. And to have the cat sprite jump, all we need to do is go to the orange data section and set the falling speed to a positive number. Let's say something like 20. That way, whenever the cat is in midair, the cat's falling speed will be a positive number. So when this change y by falling speed block is executed, the cat actually moves upward because falling speed is a positive number, and adding to the y position will move this cat sprite up. And we'll also change y by the falling speed right here. That'll push the cat off of the ground level and up into the air so that the code in this part of the if-else block gets executed. So let's test this out. I'll click on the green flag, I can move the cat left and right, and then when I press the space key, the cat moves up and then starts moving back down to the ground. And the reason why this code does that is because falling speed will be set to 20, which puts the cat up in the air. But since the cat's up in the air, falling speed will be changed by -2 each time this forever loop loops around. So that means falling speed will be 20, then 18, then 16, then 14. So the cat's still going up, but it's going up slower and slower. And then finally falling speed will go to 2 and then to 0, at which point the cat stops rising up. And then in future loops through, the falling speed variable becomes negative. It'll become -2, -4, -6, so the cat starts going downwards faster and faster until the cat goes back to the ground. And that's what's happening here. The problem though with this is that we can just keep pressing the space key over and over and over again and just kind of have the cat fly around. That's not very realistic. We need to add some code so that this code right here is only run if the cat is standing on the ground. We can do that by pulling this off, going to the control section, and adding an if condition. And the condition is if the cat's on the ground, which means if the cat's Y position is -130. So in the green operator section, grab this equal sign, and then in the dark blue motion category, grab that Y position bubble. And then just type -130. So the jumping code only gets executed if the cat is on the ground. So if we press the space bar while the cat's up in the air here, nothing happens. So I'll press space, and the cat can only jump when the cat's on the ground. That's pretty good, but we want to implement double jumping. So to do that, first we're going to create a new variable. So go to the orange data section and click make a variable. And we'll call this variable double jumped. And the double jumped variable will keep track of if the cat has already done a double jump after jumping. So what we want this to be is, actually, we want to get rid of this if block and replace it with an if else. So let's just drag this condition code over to the if and put that there. We can delete this block by just dragging it over the center area. So at the very start of the program, let's set double jumped to be the value false. So variables can not only contain numbers, they can also contain text. And so this code causes the cat to jump up but only if the cat's on the ground. Otherwise, if the cat's up in the air when the space key was pressed, the code in here will be executed. And we want that code to also check. So we want that code to check if the cat has done a double jump yet. And we'll say that the double jumped variable will be set to false if the cat hasn't, and true if the cat has. So in the green operator section, grab this equal sign. In the data section, grab that double jumped variable. And only if double jumped is equal to false do we want the cat to jump again. We can just copy this jumping code right here by right-clicking on that and selecting duplicate, and putting that in there. And then we don't want the cat to be able to do another double jump until it's fallen back onto the ground again. So in here, in this part of the if-else block, we'll add another set double jumped block that says false. And after the cat does this double jump, we want to set the double jumped variable to be equal to true. That way the cat can't do another double jump after that. So grab this set block and set double jump to true. Now if we test this out, you can see the double jumped variable here. When I click the green flag, the program begins, and so double jumped is set to false. And when I do a single jump, double jump is still set to false, but when I do the double jump, then double jump is set to true. And so if I click on the space key a third time in that jump, we'll notice that, well, the cat's in midair, so it jumps to the else part, But then it'll see that double jump will be equal to true, which means that this condition is false, so it skips that jump code and then ends up doing nothing. And that's why we can't do a triple jump. So that's the entire program. Thanks for watching. Hello and welcome to the Invent with Scratch screencast. I'm Al Swigert, and in this screencast we're going to make a basketball game. So this game has a lot of the same things that our double jump demo had, except now we also have a basketball that we can try to throw through this hoop that's constantly moving around. Oh. Got it. Alright, let's see how this game is put together. Go ahead and click on the Create button to start up the Scratch editor. And as I said before, this code will look a lot like the code from our double jump example, so we'll have moving left and right while doing the walking animation, and also jumping up and have gravity pull the player down. And gravity will also pull the basketball that we throw down as well. So the very first thing that we'll do is go to the Brown Events section and grab that When Green Flag Clicked block, and then add a forever loop underneath that. And this forever loop will constantly be checking if we're holding down the left and right arrow keys to move the cat to the left and right. So from the light blue sensing category, grab this key space pressed block and click on the black triangle to change this to the left arrow. And so when the left arrow key is pressed, we'll want to move to the left. So click on Motion, and then how about instead of changing X by a certain number, we'll actually just change the direction of the sprite. I'll click on the black triangle and select left, and then we'll just move 10 steps in the direction that the sprite is facing. At the same time, we're going to go to the purple look section and grab this next costume block, and that'll switch the costume to the next costume on this list. And so it'll constantly switch back and forth and give us this nice walking animation. We can test this out by clicking on the green flag. Oh, that's kind of weird how the cat just walks upside down on its head. We can fix that by clicking on the info panel for this sprite, and then changing this to the left-right rotation style. That way the cat is always facing upright no matter which direction it's facing. And I'll rename this sprite while we're here, Cat. So we'll need this same code for moving in the right direction, but instead of going through the different categories and grabbing all those blocks again, I'll just right-click on the If block and then select Duplicate from the menu, and then snap that into place right under there, and then you just make some changes to have this go in the right direction. So if the right arrow key is pressed, we'll want to face in the right direction. Move 10 steps can stay the same because we'll just move in the direction that the sprite is pointed to, and next costume will stay the same. So we can test this out by clicking on the green flag. Alright, click on the red stop button to stop the program. Next, we're going to have to add code that implements gravity. So if you remember from the double jump demo, if the cat is ever above the ground level, then we want gravity to start pulling the cat down faster and faster until the cat is at the ground level. But because the cat's falling down, the cat might fall past the ground level. So we also want to add code that detects if the cat is underneath the ground level, and then just set the cat at ground level. So we can do that by first clicking on the orange data category and click on Make a Variable. And we'll call this variable cat falling speed. Now go to the orange control section and grab an if-else block. If the cat is beneath the ground level, then it'll snap the cat back to ground level. Or if it's in midair above ground level, then the cat starts falling back towards the ground. So I'll go to the green operators section, grab this less than block. We'll say the ground level is the Y position of -130, which means the cat will be right here. So we can go to the dark blue motion category and say when the cat's Y position is less than -129, we'll go ahead and just set the cat's Y position to -130. And then also we'll set the cat's falling speed to 0, because if the cat's on the ground, the cat's not going to be falling anymore. Otherwise, we'll say the cat is in midair, so in that case we want to change the cat's falling speed by -2. And finally, after this entire if-else block, we'll want to change the cat's Y position by whatever value is in cat falling speed. So go to the blue motion category and grab that change Y by. And we'll change this not by this static number 10, but by whatever number is in cat falling speed. So let's test this out. Click on the green flag. We can pick up the cat with the mouse. And you can see the cat falls faster and faster. So the cat's falling speed starts off at 0, and when I let go, the cat's falling speed gets more and more negative, and that causes the cat to move faster and faster downwards. And now if we want to implement jumping, all we have to do is move this over, and I'll stop the program. But let's go to the brown events category and grab this when space key pressed button. And we use the left and right arrow keys to move left and right, so let's use the up arrow to make the cat jump. Now we only want the cat to be able to jump if the cat is already on the ground, so let's grab an if block, and if the cat is on the ground, that is, if the cat's Y position is exactly -130. So Y position from the dark blue motion category, and 130. And to make the cat jump, we just have to set the cat falling speed variable to some positive number, say 20, and then move the cat off the ground. So change Y by the cat falling speed. So this will set cat falling speed to 20, and move the cat off the ground, at which point this condition will be false, and so change cat falling speed will constantly be subtracted by 2. So at first the cat changes its Y position by 20, so it goes up, and then by 18, so it goes up again, but a little bit less, so it slows down a bit, and then 16 and 14, until finally it gets to about 4, 2, and then 0, where it stops rising, and then 0 minus 2 is -2, so then the cat starts moving downwards, because changing the Y value by a negative number moves the cat down. So we can test this out. I'll just press the up arrow key. Perfect. Now let's add the basketball sprite, and Scratch gives us that already, so we can click on Choose a Sprite from Library. And go to the Things category. Here it is, Basketball. Now we don't always want the basketball to be on the stage. We want it to be hidden until the player presses the space key, at which point the basketball will appear wherever the cat is and then be thrown in a sort of arch. So first things first, let's go to the brown events category and grab that when green flag clicked block. And then go to the data section, and we're also going to make a new variable called score that keeps track of how many baskets the cat has made. And so at the very beginning of the program, we'll want to reset score back to 0. And then the basketball should just hide itself at the very beginning of the program. And the basketball doesn't really do anything, it just stays hidden until the space key is pressed. So grab that when space key pressed block. First we want to go to the cat. So remember, the basketball's still hidden, but we can still move it around. So go to the dark blue motion category, grab this go to block, and click on the black triangle to move it to the cat. And then we'll click on Looks to show the block, to show the basketball, and we need to give the basketball its own falling speed variable. So click on the orange data category and click on Make a Variable, and we'll say this variable's name is basketball falling speed. And we'll go ahead and set that basketball falling speed to a positive number so it moves up. And then go ahead and move it off of the ground level, since it'll be at -130, since we just moved it to where the cat is. That is, if the cat throws it while it's on the ground. So grab the Change Y by block, And we'll just change this by basketball falling speed. And now go to the orange control section. We won't need a forever loop. We'll just use this repeat until loop. And we want this basketball to be thrown up and moving as gravity dictates until it reaches the ground level, at which point it'll disappear and be hidden just like it was at the very beginning of the game. So as long as the Y position is less than -1. So grab Y position is less than -129. We'll always have the basketball move forward by, say, about 8 pixels each loop. And then change Y by the falling speed. And just to make it look a little interesting, we'll have the basketball slowly rotate as it's being thrown. Not that much. We can just grab this turn right and have it rotate by 6 degrees. And after it reaches the ground, it'll exit through this loop and continue on. And so at that point, we know it's on the ground level again, because this condition will be true. At that point, hide the basketball. Let's test this out. Wow, that didn't work at all. The reason that happened is because we don't actually ever change the basketball falling speed. It's just constantly 24, so it's only going to go up. We need to go back to the orange data section and change the basketball falling speed by -2. So let's try that again. Yeah, that seems to work pretty nicely. Next, let's draw that basketball hoop that'll float around. So I'm going to click on Paint New Sprite. And I'll just make it a red hoop. So let's switch to vector mode and choose the ellipse tool. And just draw a loop. That's a pretty good sized loop. And be sure to center the hoop right in the center of the sprite where those crosshairs are. And the code for the hoop is going to be pretty simple. All it does is just hover around the screen randomly. So go to the brown events section. When the green flag is clicked, it'll enter into a forever loop. And we just want it to glide around. So go to the dark blue motion category and grab this glide block. And the X and Y coordinates that it'll glide to will be completely random. So let's go to the operator section and grab these pick random blocks and put those in for the X and Y. And we can just change these to, say, anywhere from X of -240 to 240. And a Y from -50 to the very top of the stage at 180. Alright, now we want some code that detects when the basketball has made a basket. And we could add code that just detects when the basketball... I'll go ahead and make it show itself. We could just detect when the basketball is touching the hoop, but then it would also score a basket if the basketball is just slightly touching the hoop. So if the basketball fell like this, we really wouldn't consider that to be a basket, but our code would. So we need to do something a bit more specific to make sure that the basket only registers if it touches the center of the hoop. And to do that, we'll go ahead and make a new sprite. Paint New Sprite. And this sprite will be incredibly simple. We'll just make it a single white pixel at the very center. So it's kind of hard to see the mouse cursor, but just click once. Right there. And so our sprite is sort of impossible to see on the stage because it's just one tiny white pixel somewhere here. But if we go to the script section, the only code that we need for this hoop center is to always follow where the hoop is going. So in the events category, grab that when green flag is clicked, and it'll enter into a forever loop. And all this hoop center sprite does, in fact, that's what I'll name it, hoop center. And this will be hoop. The only thing that this hoop center sprite does is follow the main hoop sprite, and it'll be centered right in the center of that sprite. So go to the dark blue motion category and grab this go to block and go to hoop. So now, as this hoop is moving around, the hoop center sprite is right there in the center of it. So now we can have the basketball detect if it touches the center hoop sprite rather than just anywhere on the hoop. Hoop, hoop. You ever say a word so often that it stops sounding like a word? Hoop, hoop, hoop. Anyway, let's go to the basketball code and add some code here while it's in midair that detects if it's touching the hoop center. So what we need is an if block right here. And then we'll go to the blue sensing category and grab this touching. And if it's touching the hoop center, then go ahead and increase the score by 1. So grab this change variable block. The variable we want to change is score by 1. So let's try this out. Click on the green flag to test it. That's pretty good, except that's sort of weird how the score is now 4 even though we only made 1 basket. And the reason that happens is similar to the reason why the Whack-A-Cat game that we did previously registered multiple points for 1 hit. Inside this loop is looping so fast that before the basketball has a chance to get away and not touch the hoop center, we've already looped through here 4 times, which is why this change score by 1 block was executed 4 times. So we need to add a new variable that will detect when this is the first time that the score has been changed. So go ahead and click on make a variable, and we'll have this be named made basket. And we'll set made basket to false when the player first hits the space key. So that'll reset it back to false each time the player throws a basketball. And whenever it does score a point, we'll set made basket to true. But then we only want the program execution to enter this if block if it's both touching the hoop center and also if made basket is false. So we'll need to go to the green operators section and grab this and block. So touching hoop center, but also made basket has to be equal to false. So the first time it enters this if block, made basket will be equal to false, so it changes score by 1, but then it also sets made basket to true. That way when it loops again, this part of the condition will be false, so we skip this if block, and we won't execute change score by 1 again until the next time that the player presses the space key, and that's when we reset made basket to false. So let's test this out. Oh, that's kind of nice. Let's add some visual indication that the player has made a basket. Go to the brown events category and grab this broadcast block. And we'll broadcast a message called swoosh. And that's the basketball sprite telling the hoop sprite to go ahead and say swoosh. So when I receive swoosh for the hoop sprite, we'll just go to the purple looks category and have the basketball hoop say swoosh for just for 1 second. That's kind of weird though. We still get a point even if the basketball comes up from the bottom of the hoop. We really only want it so that the basketball has to be coming down through the hoop before it scores a point. So we're going to add one more condition to this if block. So we'll go to the green operator section, grab another and, put this and block in that and block. And we want the basketball to be moving down. That means the basketball falling speed variable has to be equal to 0 or less. So we'll have to go to the operator section, grab this less than, and we'll just have basketball falling speed. We'll just say it has to be negative, so if it's less than 0, And that will be the full condition of that if block. So the basketball has to be moving down, which we can tell is happening if basketball falling speed is negative. And made basket has to be false, and it also has to be touching the hoop center. Let's test that out one more time. I'm going to hide these variables because we don't really need them. Great. And yet if we go from the bottom and up through the hoop, it doesn't count. So that's our entire basketball game. You can add more code to fix the cat from throwing the basketball to the to the left when the cat is facing to the left. That's kind of, well, it's a trick shot. Cat can even make baskets backwards. Oh, except that time. Wow, I'm really lousy at this game. Okay, but I hope you found this screencast to be helpful, and you can find more screencasts at inventwithscratch.com. I'm Al Swigert, thanks for watching. Hello, and welcome to the Invent with Scratch screencast. I'm Al Swigert, and in this screencast we're going to make a meteor dodge game where we have this tiny little spaceship that is really agile but doesn't move too fast, and we have to avoid all those meteors that come down for as long as possible so we can get this time score as high as we can. So let's see how this game is put together. Click on the Create button to start up the Scratch editor. The first thing we're going to do is get rid of this cat sprite because we don't need it, so right-click on the sprite and select Delete. And instead we're going to add a new sprite from the library, so click on Choose Sprite from Library. It's underneath the Transportation section. So we're going to have to make a few changes to this sprite first. Go ahead and delete that second costume, we won't be needing it. And also, select the entire spaceship with the Select tool, and go ahead and grab this top anchor point and rotate it over so that it's facing to the right. And the reason we do that is all sprites start off facing to the right, and we want the direction that the sprite is facing to be where the nose of the spaceship is pointed. And then we're going to make this a little bit fancier. Go ahead and right-click on this first costume and duplicate it, and then duplicate it again. And we're going to make our spaceship a little bit fancier by adding these power rings that are shooting out from the back. So click on the ellipse tool and maybe get that nice light blue color and make the line a bit thicker than normal. And so we'll just draw a little ring here. And then for the second image, we'll draw a slightly bigger ring that's further away. And then an even bigger ring for the third frame of animation. So this will look like the rings are shooting out from the rocket. This rocket is way too big, so I'm going to click on the Shrink tool and shrink it down to about this big. And while we're making changes, let's click on the stage and change the background to one of the backgrounds that Scratch provides. Click on the Choose Backdrop from Library button, and the backdrop that we want to use is called Stars. Great, let's go back to the spaceship sprite and add the code for this sprite. At the very start of the program, when the user clicks on the green flag, we'll want to move the spaceship to the very center of the stage. So in the blue motion category, grab that X and Y and set both the X and Y values to 0. And since we'll hide the spaceship at the end of the last game, we'll want to make this spaceship show up at the very start of the game. So grab a show block and snap it into place right under there. Now we'll enter a forever loop, so go to the control section and grab a forever block. And all this code is going to do is have the spaceship follow around the mouse cursor. So in the blue motion category, we want the spaceship to point towards the mouse cursor and then move a few steps towards it. And 10 is too fast, so we're going to make this slow down a bit, down to 5 steps. And then to play the frames of animation, we'll go to the purple looks section and grab that next costume block. So we can test this out. That looks pretty good. Also, we'll want to add a little timer in the top left. So first we'll create a variable in the orange data section. Click on Make a Variable. The variable's name will be time. And so at the very start of the program, we're going to have time start off at 0. So when the green flag is first clicked, we're going to set time to 0. And then we'll enter into a forever loop here. And we want the value in time to be the number of seconds that have passed since the very start of the game. So we'll add this wait 1 seconds block. And we'll change this down to a tenth of a second, 0.1. And then the orange data section will change the time value by 0.1. So when we run this, we can see that the time variable is sort of like a stopwatch where it's counting up how long it's been since the very start of the game. Next, let's draw some meteors. So click on the Paint New Sprite button. And drawing these meteors is going to be pretty simple. We'll select a bright yellow color first. And with the paintbrush tool, draw a little teardrop shape facing to the right. We can fill that in with the Paint Bucket Fill tool. And once we have that yellow teardrop, go ahead and right-click on it and duplicate it to make 4 identical costumes. This way it'll have the same yellow core, but we'll have different red flames around each costume. So with the paintbrush tool, just draw an outline of where the flames will be around the yellow core part. And we can make it flicker out towards the back. It doesn't have to look perfect, but the random, irregular look to all these costumes will make it look like the flames are flickering behind it. And maybe we'll just draw some sparks coming from out the back. We can see what this animation looks like if we just temporarily grab one of these forever loops and put a next costume inside of it. And then double click it to run this loop. That looks pretty good. So let's rename this sprite to Meteor 1. And we'll add all the code for this sprite and then make several duplicates of it afterwards. So the code for the meteor is pretty simple. Let's start off with when the green flag is clicked and have a forever loop. And what the meteors will do is first hide themselves, and then wait a random amount of time. That's just so that they all come down at different intervals. And then they will move themselves up to the very top, and then place themselves randomly somewhere at the top, and also point down at a random direction. And once they're in position, they'll show themselves and start moving down, meanwhile seeing if they're touching the player and broadcasting a game over message if they ever do. And then once they hit the bottom, they'll just hide themselves again and then start the entire process all over again. So let's go through that step by step. First, in the purple looks category, grab the hide block. Next, we want to have it wait a random amount of seconds, so in the orange controls section, grab that wait 1 seconds block, and since we want it to be a random number of seconds, we'll grab this pick random 1 to 10. We don't want it to be that long though, just 1 to 5 seconds. There's actually kind of a problem with this. Pick random 1 to 5 will only return the numbers 1, 2, 3, 4, or 5, so it'll always be right at that 1 second interval that all of these meteors will be coming down. That's not really that great. It would be nice if we could have it just wait maybe 2.6 seconds or 4.2 seconds. And there's a way we can do that with some clever math. Pull this out for a little bit, and let's change this to 10 to 50. And then grab this division operator block and put that in the front, and then have that divided by 10. Now this pick random 10 to 50 will have a value like 26, which gets divided by 10, so then that'll be 2.6 seconds. That'll give us much more random downward pourings of these meteors. So now we have to set it somewhere randomly for its x value. Go to the blue motion category, and we'll just set x to some random number. Go to the operator section and grab that pick random, and it can be anywhere from negative 240, which is on the far left side, to 240, which is on the far right side. And then we always want it to be at the top, so let's set the y value to just positive 180. That'll be at the very top. And then we also want it to point downwards, so point in direction. And actually, we don't always want it to point directly down, which would be 180 degrees. We want it to vary to the left and right a little bit. So let's grab this operator section and grab this plus sign. So we want it to be 180 degrees plus or minus, say, 25 degrees. So we can grab that pick random block and say, pick a random number between negative 25 and 25. So that'll add a little variance in where it's pointed. It'll still generally be pointed downwards, but it just won't always be straight down. And snap that into place. Now that the meteor is in position, we can go ahead and show it. And now we'll want it to enter into a loop and keep moving downwards. So go to the control section and grab this repeat until block. Now we want this meteor to keep moving down and also keep checking if it's hit the player until its y value reaches something less than negative 160, say. So in the operator section, grab that less than operator. And in the motion category, we'll get the y position of the meteor. And if the y position of the meteor is less than negative 160, then we'll stop looping in this loop and continue on. Actually, after that point, we'll just have it loop back to the top of the forever block and then hide itself and wait a random amount of time and then start falling down all over again. But meanwhile, while it's in this loop, we want it to move downwards, so grab this move 10 steps block. We also want it to animate by changing the costumes through those different frames of animation that we have. So click on the purple looks category and grab this next costume block. And then we also want it to check if it's touching the spaceship. So go to the control section and grab this if block. We want to see if it's touching the spaceship. So the light blue sensing category has these touching blocks, and we can just set that to spaceship by clicking on the black triangle. And in that case, we'll have it broadcast a game over event, and we'll reprogram the spaceship to handle that broadcast. So this will be a new broadcast message. So click on new message, and then type its name, game over. So let's add the code to the spaceship sprite to handle when it receives the game over broadcast. So we'll grab this when I receive game over block from the events category. And in this event, we want the spaceship to hide itself because we'll have a different sprite of an explosion animate itself instead. And we also want to stop this other script that counts up the timer. So go to the orange control section and grab that stop block. We don't want it to stop the entire program, we just want it to stop all the other scripts in this sprite, particularly this script right here, which has the timer go up. So as soon as it gets hit by a meteor, the game over message is broadcasted, and then it will stop this other script up here. So let's test this out. And the time's still going up. And then perfect. So let's make a cool explosion sprite that can play once the spaceship gets hit by a meteor. Now we could draw this ourselves, but it's kind of tricky. Instead, we could just download an image of an explosion animation off of the internet. So I'm going to go to inventwithscratch.com in my web browser. And here in the download section, you'll find a whole series of these explosion images. So right-click on each one of these and save link as to download them to your computer. Okay, that's explosions 1 through 8. And back at the Scratch editor, you can create a new sprite by uploading an image from your computer into the editor. So I'll start off with explosion 1, and then for that sprite I'll go to the costumes tab and upload different costumes from each of these explosions. So I have 8 different costumes for this explosion. The script section for the explosion sprite is pretty simple. All it does is at the very start of the program is it hides itself since it doesn't need to be seen until the ship gets hit by a meteor. And then it will just wait until it receives that game over sprite. So grab the when I receive block from the brown events category, and let's make sure it starts off with the very first costume. So in the purple looks category, grab that switch costume block and switch it to explosion 1. Then we also want the explosion sprite to be wherever the player's spaceship was. So in the blue motion category, grab this go to block and click on the black triangle to set it to go to spaceship. And now once it's in the right position with the correct costume, go ahead and show it. So in the looks category, grab this show block. Now all we have to do is have it run through all the different costumes. Now we could have 8 of these next costume blocks all in a row, but instead, let's go to the orange control section and grab this repeat loop block. We'll just set it to repeat all the code inside of it 8 times. And now we can just grab one next costume block and have that executed 8 times. But just so that we don't have it play as quickly as possible, let's add a slight delay from the orange control section. Grab the wait 1 seconds block. 1 second is way too long. We just want it to be a very, very short delay, something like 0.03 seconds. And then after the explosion animation is played, we'll want this sprite to hide itself. And even though at this point the spaceship is blown up, let's give the player a chance to just consider the dark, vast emptiness of space. 2 seconds should be good enough for that. So let's go to the orange control section, grab this block, and say wait 2 seconds. And then after that, we'll terminate the entire program with this stop all block. Okay, let's try this out. Click on the green flag to start testing it. Nice. And it waited for 2 seconds, and then it automatically stopped. So one meteor isn't that tricky to avoid, but let's start duplicating this sprite over and over and over again. The more meteors we have, the harder it will be to dodge them all. So I'll maybe go for 10 meteors. Whoa, they're coming down pretty hard. So that's it for this program. Oof, that was impossible to dodge. Anyway, that's it for this screencast. In this screencast, we learned how to make our own little animations for a spaceship and also for this meteor, but also how to download different animation images from the internet and then upload them to the Scratch editor so that we can play through really complex looking animations that other people have made. So I hope you found this project to be helpful. Thanks for watching.
The Scratch team at the MIT Media Lab has been working on a new generation of Scratch, Scratch 2.0. Our goal is to enhance creativity and collaboration with Scratch so that you can create new types of projects, work together in new ways, and learn new things in the process. Let's check out some of the new features in Scratch 2.0.
On the new homepage, you can follow what other people have been doing in Scratch recently, and now you can scroll through the rows of projects and see many more. On the new project page, you can run the project, favorite the project, love the project, and write comments. But now you can do even more. In Scratch 2.0, you can see inside to see how the project was made, and you can even experiment with the code.
The new paint editor is built right in and uses vector graphics, so the images can scale to different sizes without getting jagged.
With Scratch 2.0, I can open up the backpack at the bottom of the screen and drag in the costume, go to a different project, and drag the costume into the new project. Remixing is as easy as that. I can even drag scripts and sounds and sprites into the backpack too.
This project also shows another new feature of Scratch 2.0. You can now create your own programming blocks. Here I created a jump block. Each time I click on jump, the creature jumps.
In Scratch 2.0, my profile page is where I present myself to the rest of the Scratch community. I can feature one of my projects, and I can tell people about myself and what I'm working on. People can also see my collection of projects, my favorites, my galleries, other Scratchers that I'm following, and who's following me. There's also a place where people can write comments to me.
Let's check out this other feature of Scratch 2.0, Cloud Data. Now you can store variables and lists online, and everyone can access the same data. This is an online survey where everyone can vote on their favorite Scratch sprite, and the results are stored online. Cloud data can also be used to create a high scores list for a game. With the new cloud variables, you can keep track of scores for everyone who's ever played the game.
Another new feature in Scratch 2.0 is cloning. That means you can create copies of a sprite from within a script. If I look inside, there is just a single sprite, but it copies itself over and over when I press the spacebar.
One final feature. With Scratch 2.0, you can use the webcam on your computer to detect body movements in the world, somewhat like the Microsoft Kinect. Here's a project where you can pop balloons on the screen just by moving your arms.
All of us on the Scratch team are excited to see what Scratchers around the world do with Scratch 2.0. We can't wait to see what you create.
Hello and welcome to Getting Started with Scratch. Scratch is a programming language available from the MIT Media Lab. So what is Scratch? Scratch is a programming language, but it's specifically designed for education. Consequently, it's easy to use and it's designed for people of any age or experience level. It's designed to be visual, colorful, and graphical, and it uses kind of a Lego blocks approach, where you connect different blocks together to build a program. And it's mostly designed to be fun. So where do you get Scratch? Well, Scratch is available from the MIT Media Lab, and it was actually developed by a group that has the fun name of the Lifelong Kindergarten Group. You can download it directly from their website at scratch.mit.edu, and it's available on a number of different operating systems, including Windows, Apple, and Linux. So to download Scratch, first open your browser and point it to scratch.mit.edu, and click the Download Scratch button. You'll then see a form, which you should fill out. And by the way, if you're under 13, don't fill out your email address information. And then finally click Continue with Scratch Download. This will take you to a new screen where you can choose which one of the operating systems you want to use. Just click on the program to download it to your computer. After you download and install Scratch, you can start it by double-clicking the desktop icon or by clicking the program from your Start menu. So let's get started. When you first start Scratch, this is what you'll see on the screen. So you'll see the little Scratch character, and Scratch tends to call this a sprite, although I tend to call it an actor. And the actor works on a stage, this big white area here. This empty area is where we're going to write a script. And we create that script using the functions shown on the far left. So we can change what how the actor moves, what he looks like, the sound he makes, control various functions, and then there's more advanced capabilities that I'll talk about later. But let's do something really simple. So let's say I want the actor to move on the stage. So I'll come over to Motion, and one of the functions I have here is move 10 steps. So what I can do is just click my mouse and drag it over here to my script. And by default it says move 10 steps. But let's say I want him to move 100 steps. There, I've just written a program. Now the great thing about Scratch is you can build things and test them and you don't have to worry about hurting anything. So if I want to try making my actor move here, all I have to do to run my program is click on it. And if you notice on the stage, my actor's moved off the stage. So I'm just going to drag him back on here for a second. So I don't want to move it all the way off the stage. So let's say that every time he moves 100 steps, I want him to turn 90 degrees. So in this case I'm going to turn clockwise or to the right. And to make it 90 degrees I just change it to 90. And there, again, if I click on it, I can make him move 90 degrees. Now if I want him to move and then go 90 degrees, all I have to do is drag this block into this block and see how it lights up, and it'll automatically snap together just like Legos. So every time I click on it, my little actor will move 100 steps and turn 90 degrees. And again, and again. Now instead of having to click to have him do that every time, I can control how he does that. So here's my little control features, and I'm going to grab a block here called repeat. Now repeat says how many times I want to do something. So I want him to move and turn 4 times. You notice there's a space here, and in that space I'm going to take my existing program and I'm going to drag and drop it into here, and notice how the control box automatically surrounds the function that I created. So now let's watch what happens when I click on that function. Gotta look fast because he moves quickly. That's probably too fast. So let's make a modification to our program. Now in order to grab this little piece, again I just click and drag. Notice I can just take it right out of there. And I'm going to put a little function in here, so I'm going to drag this one down. And what I want the program to do is move 100 steps, and then I want it to wait 1 second. So again, I'm just going to have to hook these together. Now I grab this entire block, put it back and repeat. Now watch what happens. So I get a nice little wait in there so I can see what's going on. And to make things a little more interesting, I can also add a pen. So I'm going to say pen down. And now when I run my program, look what happens. So it creates a little box. Now, if I'm playing around, I might mess things up a little bit. And that's okay, because I can also create a function to make things all nice and neat. So I can clear my screen. We'll add a little more complexity to that in a second. So let's say that I want to make something a little more complex. I'm going to keep moving 100 steps. I'm going to take this entire program out for a second, and I'm going to remove the wait function. And if I want to delete something, I just right-click the mouse button and hit delete. Okay, I'm going to put this back in here. So we're going to move 100 steps, and instead of turning 90 degrees, I'm going to do something a little bit different. I'm going to go 105 degrees. And I'm going to have him do this, let's say, 5 times. Now watch what happens. So now he's kind of turned off in a strange direction. If I keep running this over and over again, it makes a nice little geometric pattern. But now if I hit clear, the actor stays at the same angle in the strange position that he's in. So let's see if we can't fix that a little bit. So let's go back to motion. And one of the things I can do is say I want him to go to a specific location on the stage. Now the middle of the stage is at location 0, 0. So this is the X direction, and it goes from minus about 240 to plus 240. And up and down is the Y direction, and again it goes from minus about I guess about 180 to plus 180, and you can see where the mouse is pointing at any point in time down there. Okay, so I want my actor to return home to location 00. And oops, he's got a little line here, so I probably want to do my clear after I do that. And I want the actor to point in the direction of 90 degrees. So let's see what happens when I run that. And so he's back to normal. So I can run my function as many times as I want and always return home. I can also clean up my script just by, again, right-clicking on the mouse, clicking clean up, and it'll make everything nice and pretty. So again, this is my actor or my sprite. Back here is the stage. And down here it shows you the different actors that are on the stage and the stage. So instead of a boring stage, it's all just a plain white field. What I can do is change the background. So I've clicked on stage, and again I can write a script for that if I want. But I'm going to go over here to backgrounds, and I'm going to import a picture from those available inside Scratch. So let's add something from nature, and let's give it a desert scene. And now I can go back to my sprite, go back to my scripts, and I can run my little function there. And again, I can clean up afterwards. Now you can also change the sprite or add a new one if you like. So for example, on this one, I can delete this actor, and notice it also deletes the script, so remember that. And I can pick a new sprite from a file. So for example, I can pick one of the animals. So let's say that I really like buffalo. So there we have a buffalo on our stage. Now if it's not something that I like, I can pick something new. So I can actually paint my own sprite if I want. So you can use all kinds of drawing tools and make your own. Or you can import a sprite from someplace else in your system. So again, Scratch has a large number of sprites as part of its system. And that's kind of a quick and dirty introduction to the Scratch development system.